Welcome to this NISO Dairy webcast, one of a 4-part series addressing key opportunities and challenges for the dairy industry. I'm Raymond Kiviet, Innovation Accelerator at NISO. In each webcast, we focus on particular areas of interest for the dairy industry, optimizing processing, food safety and chain control, health benefits, and the protein transition. Today, Dr. Nathalie Hottrom will talk about how to design healthier products and substantiate the health impact. Nathalie's areas of expertise include physical chemistry, food science, emulsions, dairy, infant and medical food technology. In addition, she has an interest in the use of in vitro digestion models to investigate the physical chemical changes to food when subjected to conditions that mimic the physical conditions of the human gastrointestinal tract.
Hello, my name is Nathalie Hottrom. I'm a Senior Project Manager in NISO's Food Division. Among the opportunities facing the dairy sector, we see increasing consumer demand for healthier products, as well as for products perceived as more natural, with fewer additives. There is also a greater market interest for products enriched with health benefit ingredients, such as prebiotic fibers, bioactive proteins, and probiotics. Dairy has an important and unique place in the market for food products, with many industrial and consumer applications, everything from cheese and yogurt to ice cream and milk powders. But for all these products, the constituents are identical, the same proteins, minerals, carbohydrates, and fats. Only the concentrations, ratios, and environments vary, enabling us to create multiple product matrices and health impacts. Furthermore, because milk is already a liquid, it fractionates quite easily into its respective components, including milk fat, whey protein, casein, lactose, and minerals. Each fraction can be further fractionated into its individual components, with just a few examples shown here. In summary, milk is an ideal basis for the products I mentioned before, but also for high-value ingredient applications such as infant, sports, and medical nutrition. And the industry continues to develop new ingredients to meet evolving market and consumer demands. The dairy industry thus faces a dual challenge to develop products that are healthier and to substantiate those health benefits. When we look at developing or adapting dairy products and ingredients, we need to consider 4 levels of consumer expectations. The first level is trust. For example, the product has to meet food safety standards, it has to look familiar, and the consumer has to know how it is used or consumed. The second level is the product's performance. Does it taste, smell, and feel right? Does it have the desired mouthfeel? Does it provide the expected functionality? For example, foaming, melting, or other desired characteristics. The nutritional level covers protein quality, the balance of nutrients, including vitamins and minerals, but also the consumer's perception of the health impact of the product and its potential benefits. And the final level is society. Consumers today want products they perceive as natural, with a minimal environmental impact, for example. Today, we will focus on the nutrition and health aspects, but it's important to note that these levels are not independent. You cannot change, add, or remove one element and expect everything else to remain the same. If, for example, you want to reduce the stabilizers in ice cream to have a cleaner label, how will that impact the nutritional composition of your product? Or, if you want to add a prebiotic fiber to your yogurt, what will that do to the mouthfeel and taste? You have to look at the entire picture. Your journey to developing or adapting a healthy product can be approached in 2 ways. You can start with the ingredient composition and move towards a desired health impact, or you can start with a desired health impact and translate that back to the required ingredient composition. For example, you may have an ingredient with a potential health benefit that you wish to use in a product, but you need to confirm that this health benefit will not be impacted by the processing conditions or other characteristics of the final product matrix. On the other hand, you may want to target a specific health impact with your product. In this case, you need to find the best health ingredient and determine the optimal product matrix and processing conditions. To see how this can be achieved, we will take a journey through the human digestive system, from mouth, through the gastric chamber and small intestine to the colon, in order to explore the development and substantiation of perceived health benefits in dairy foods and ingredients at each of these points along the way. We'll do this through 4 cases from NISO. Firstly, using dairy protein to create clean-label, low-calorie ice cream without additives. Secondly, observing the potential role of the product matrix on the rate of amino acid absorption in the gut. Thirdly, exploring the potential health impact of soluble fiber as a prebiotic, and finally, using dairy foods as a matrix for probiotics. There is a general need for a food to have fewer calories while offering a pleasant sensory experience. This creates a market demand not only for products seen as healthy, such as yogurts, but also for lower calorie versions of products that are considered indulgences, such as ice cream. However, consumers don't want to compromise on flavor and richness. One very common solution has been the addition of hydrocolloid stabilizers, which increase the viscosity of low-fat ice cream, for example. But while this may answer the performance level in our pyramid of consumer expectations, it doesn't match the call for clean label products. Consumers want a low-calorie ice cream that offers significantly lower fat and calories, uses fewer and simpler ingredients, and provides the taste and mouthfeel experience of a full-fat product. Building on our expertise in dairy proteins, we developed a unique process that leverages the water-binding properties of casein micelles to substitute for the creaminess of fat and the body of sugar in the product. We successfully scaled up the process from laboratory to the factory and created an ice cream with 28% fewer calories and less than 1% fat. In informal taste tests with industry experts, 86% said it was tasteful or very tasteful. The open feedback was very positive, and this was achieved using only the natural properties of dairy proteins. No other additives were required. Moving further into the digestive system, specifically to the stomach and small intestine, let's look at strategies to increase the absorption rate of essential amino acids into the bloodstream. Among both elderly and physically active consumers, muscle building is correlated to blood amino acid levels shortly after consuming protein. So how can you develop products that optimize the characteristics of dairy proteins to increase the rate of amino acid uptake? If we compare two dairy proteins, whey protein and casein, we see that both are very digestible. However, the peak level of amino acids measured in the bloodstream is much higher for whey protein. Whey protein is therefore a popular dairy ingredient for use in medical and sports nutrition. However, in cow's milk, 80% of the protein is casein and only 20% is whey protein. Finding ways to increase the rate of absorption of amino acids from casein in your product could thus be very interesting. To develop a strategy, we need to understand the differences in the behaviors of the two dairy proteins. Using our in vitro digestion model, we simulated the conditions in the gastric chamber and small intestine to investigate the degree of protein hydrolysis. The results showed a similar level of protein breakdown for whey protein isolate and micellar casein isolate at the endpoints of the gastric and intestinal phases. But what explains the difference in the bloodstream amino acid kinetics between whey protein and casein? We investigated the different structures the proteins form using our gastric model. This revealed that the whey proteins form smaller aggregates than casein under simulated gastric conditions. These smaller aggregates may be able to pass more quickly into the small intestine where amino acid absorption takes place. Could this explain the faster amino acid response of the whey protein? Furthermore, if we could somehow change the gastric digestion characteristics of casein by modifying the product matrix, would this speed up the amino acid response? One way to do this could be by adding plant proteins to the casein. An in vitro comparison of the digestion of milk protein concentrate, soy protein isolate, and mixtures of the two showed that rather than forming separate aggregates for the casein and the soy particles, the proteins instead created a true hybrid. As soy protein levels increased, we observed a decrease in casein aggregate size compared to the pure casein. This opens up exciting possibilities for the protein transition and the opportunity to restore the balance and mutual benefits of dairy and plant proteins. For example, could those smaller aggregates contribute to an increased rate of amino acid uptake for the hybrid protein mixture, and even to a level comparable to the whey protein? Moving into the colon, quite a bit of attention is currently being paid to prebiotics. These soluble fibers, such as oligosaccharides and polysaccharides, are not digestible by humans. They thus arrive intact in the colon, where they can act as food for beneficial gut bacteria. The milk-derived prebiotic galacto-oligosaccharide, or GOS for short, is produced from lactose using the enzymatic process of intermolecular transgalactosylation. Galacto-oligosaccharide is particularly interesting as a health ingredient because it promotes the growth of bifidobacteria. During their metabolism, these bifidobacteria produce vitamins and short-chain fatty acids, which have health benefits. Moreover, bifidobacteria contribute to a healthy gut microbiome, and their presence in the gut can help prevent pathogenic bacterial infections. The production of organic acids is a key marker for the growth of these beneficial bacteria, making it possible for us to measure the prebiotic effect of soluble fibers under simulated gut conditions in the NISO microcolon model. This model mimics the luminal contents of the large intestine and simulates the effects of the prebiotics on microbial composition and metabolic signature using samples from human volunteers. Using this model, we observed increased organic acid production in response to a galacto-oligosaccharide compared to its reference without added prebiotics. This can most likely be attributed to the bifidobacterial growth and/or activity. However, it is important to keep in mind that not all soluble fibers are equal. New fibers are entering the market and can have different yields, sources, molecular structures, physicochemical characteristics, and sensory properties, depending on the products and the processes they are put through. But most importantly, they can have different prebiotic effects. Our microcolon model can help determine in a fast and cost-effective way whether a newly developed soluble fiber has prebiotic properties and promotes the growth of specific bacteria in the gut. In summary, it is very important, firstly, that you select the right prebiotic to deliver the desired health benefit, and secondly, that you substantiate that benefit. From prebiotics, which support the growth of healthy bacteria, we now turn to probiotics, which deliver a dose of beneficial bacteria. Probiotics remain a big market opportunity, and dairy products offer an excellent matrix for delivering them to the consumer. Let's take the example of adding a probiotic to an existing dairy product. In this case, several probiotic strains have already been screened and their persistence through processing and storage tested, using confocal laser scanning microscopy with a special dye that reacts only with live bacteria. Now, we need to confirm their survival in the gastrointestinal tract, and ideally, gain more insight on how they impact the microbiome. The goal is to select the strain with the highest survival rate, not only in the food matrix and during processing and storage, but also in the gastrointestinal tract, so it can reach and colonize the colon. Our in vitro digestion models mimic this journey. The probiotic is exposed to simulated gastric and pancreatic juices, as well as realistic pH conditions and digestion times. We then measure its viability using cell count methods. With these insights, we can compare and substantiate the performance of the various strains, providing the insight to make the best choice for the product and application. We can also explore microbiome composition changes using our bioinformatics platform in a subsequent microcolon experiment. These cases show some of the different aspects of nutrition and health benefit substantiation for dairy products and ingredients. For more than 7 decades, NISO has been working with dairy producers to increase the value of their applications. We have developed our own culture collection, casein micelle models, spray drying models, and high-throughput sequencing platforms for food safety and chain control, to name only a few. About 2 decades ago, this background led us into plant protein functionality, and we are now using our dairy knowledge to support producers in developing plant-based dairy alternatives. Our in vitro digestion models, combined with our end-to-end expertise, can provide key insight into your products and ingredients, to characterize and quantify how the product and its components behave under conditions designed to simulate the digestive system, from mouth to colon. As part of an independent, multidisciplinary approach, they can help you to substantiate a health benefit, evaluate performance, or even screen ingredients and components to select high potentials for a clinical trial, all the while taking into account your needs for target functional properties, clean label, and product development timelines.
Dr. Nathalie Hutzel, thank you for showing how NISO provides the capabilities and expertise to support our customers in developing healthier dairy products and substantiating the health impact. We hope you enjoyed it, and we look forward to working with you to create products that meet consumers' expectations in a holistic way. See you at our next dairy webcast, which will look at the role of dairy in the protein transition and how we can rebalance animal and plant protein in food products.